All right, guys, I'm going to knock these out to do a set of solutions for you as well to help you kind of understand and make sure you're getting this. So number one, I'm just going to copy each of these so that we can do them on a separate page. Problem. Last one, only the quadratic formula. This one's not something that can be factorable. I just made this one up off the top of my head, so we'll see if it's either solutions, but without a perfect square you can take, or maybe no solution because we get a negative. I don't know, let's see. Okay, it already equals 0, so I've got an A, a B, and a C, and we just plug in. Negative B means positive 2, plus or minus the square root. B squared, that's negative 2 squared. Remember, that's going to become positive 4. You'll always have that work out to a positive. Times A, negative 5, times C, 3. All over 2 times A, negative 5. And we'll do that work under that radical. Negative 2 times negative 2 is 4. Pair of negatives cancels. 4 times 5 is 20. Times 3 is 60. So we're adding 60. So 60 and 4 is 64. Shut up. Another perfect square. That was perfect luck. I was hoping to not have one that would work out. I just randomly made one up that did. Okay, plus or minus the square root of 64. 2 times negative 5, negative 10. And so we'll split it. 2 plus 8, right? Square root of 64 is 8. And 2 minus 8. 10, and it almost works out to whole numbers. It does, that's crazy. 10 over negative 10, so we've got x equals negative 1. 2 minus 8, negative 6 over negative 10, negatives cancel. So that's just fractional, and we'll reduce it 6/10, 3/5, divided 2 out, and there's our 2 solutions. We do have 2 solutions, one whole number, one fractional. And just to be clear, if we were to graph this, we'd have one value at negative 1 and one at 3/5, which is a little more than halfway between 0 and 1. And if we look back at our original problem, the A value on the front is negative, which always tells us it goes downward. So you're basically looking at this. That would be the quadratic if we graphed it. And there's your 2 solutions on the graph. There's your 2 solutions from the quadratic formula. All right, peace out. Same idea. Set it to 0, which means it should actually be 27. And I'm going to factor out that negative because I need x squared by itself to see if I can use that trinomial method. So if I just pull out the negative, all it does is flip their signs. At that point, I can now use my simple trinomial method and see if I can find those 2 magic numbers. 27, I think 9 and 3, and it looks like those are going to work. It's multiplying to a negative, which tells me I'll have mixed signs. And since they have to add to a negative, the bigger of the 2 values would have to be the negative, which is the 9. And so there we go. And now if I set each to 0 and solve them, it'll end up flipping the signs. So my solution will be x equals negative 3, x equals positive 9. Okay, notice I did the same thing as the last problem. This was just kind of a shortcut version, a little less talking. Steps were still there, but I streamlined some of the steps. Quadratic formula, we'll do the same thing. We'll make it a little bit more streamlined this time. There it is, set equal to 0. There's my A, B, C. A is negative 1. B is a 6. And C is the 27. So I'm just going to plug right into the quadratic. Negative b, which means negative 6, plus or minus the square root of b squared, which is 6 squared, minus 4, times the a, negative 1, times the c, 27, all over 2 times a, which is the negative 1. Let's do the work under that radical real quick. 6 squared, 36. Negative times negative cancels. 4 times 1 is 4, so it's really just 4 times 27. In my head, the way I work that out is 4 times 25. 4 times 25 is 100. It's like 4 quarters make $1. And then I have 2 units left over above that 25 to make 27. So it's 4 groups of those 2 units as well. That's 8. So just add the 8 and the 100. 108. And that's going to make 36, 144. Now I'm hoping that rings a bell for you. Square root of 144 is actually just 12. So I'm going to end up with negative 6 plus 12 all over 2 times negative 1, which is negative 2. And then x is negative 6 minus 12 all over negative 2. And finally, negative 6 plus 12, that's just 6 divided by negative 2, which is negative 3. Negative 6 and negative 12, negative 18 divided by negative 2. Those negatives cancel, so x equals 9. And did we get matching solutions? We did. It'd be kind of embarrassing if we didn't. What's the math teacher doing if you can't make it work? There you go, another pair of matched solutions. There's number 2, because I don't have room. All right, first one here. I need to factor solve, and I need to do quadratic formula to solve. So let's start with factoring. We'll do it right here. Okay, first I know I need to get that equal to 0, so I'm going to rewrite that. Okay, negative 12 on the right. When I move it across, turns it into that positive 12, switches the sign, and now it's equal to 0. At this point, I'm going to factor it, and I'm always going to look for a GCF. And in this case, there's both a negative and a 2 in front of the x squared. I want to get to see if I can have just x squared in a minute after I pull out a GCF, because then I can try my trinomial factoring method on that remaining trinomial. To be able to do that, I've got to pull out a negative and a 2. Let's see if I can do that. If I factor out a negative and a 2, that'll just become x squared for the first term. I can definitely take a negative and a 2 out of that, and that just becomes plus x. And then I can definitely factor out a 2 from 12. It'll become 6. And if I also factor out a negative, it'll flip the sign to negative. So there we go. I was able to pull out a negative 2 from all 3 of those terms. And the reason being, again, and let's set that equal to 0, don't forget that. The reason being, I can now check and see if I can finish factoring this problem using our trinomial simple method, which is looking for those 2 magic numbers. I've got to have the x squared by itself to do that. So the x squared is good. There's no there's no negative, there's no coefficient, it's just 1. So I'm going to try it. I need something that'll add to whatever's in front of x, which is 1 in this case. It'll add to 1, and it'll multiply to that negative 6. So what numbers could I use? 2 and 3 seems the obvious case. And if they need to add to a positive, since they're a negative, they're going to multiply 2. The signs will be opposites, like 1 positive, 1 negative. And since they add to positive 1, I'll make the 2 negative, the 3 positive, and now they'll add correctly and they'll multiply correctly. So I've got an x minus 2 and an x plus 3. At this point, set each of those equal to 0, and then I just solve them, which means, in this case, flip the signs. So I see that x equals 2 and x equals -3. So there's my solutions if I factored it. Now, if I do it correctly, I should also get the same thing through the quadratic formula. So I'm just going to pull out my ABC. Okay, it's set equal to 0 right here, so I'll just use that version. The A is the -2. The B is also a -2. And the C is that 12, okay? Just pulling them right out of this version over here. Now I'll just plug into my formula. Negative B means the -2 becomes +2, plus or minus square root b squared, which is the -2 squared, minus 4 times the A, another -2, times the C, a 12, all over 2 times -2. So now let's do our work under that radical. -2 squared is 4, and then the 4AC, there's a pair of negatives that cancel, so it's really just 4 times 2 times 12. 4 times 2 is 8. 8 times 12, 96. And 4 plus 96 is just 100. So it's really just the square root of 100. That's kind of nice. So we have 2 plus or minus square root of 100 over 2 times -2, or -4. So at this point I'll split, and I'll take that square root. So it's really going to be 2 plus square root of 100 is 10 over -4, and then 2 minus square root of 100 is also 10 over -4. 2 plus 10 is 12, so 12 divided by that -4 is -3, and 2 minus 10, -8, divided by -4, pair of negatives cancel, so x equals 2, and there we go. I've got the same solution both ways, so I've shown I can factor to solve this quadratic, and I can use the quadratic formula to solve this quadratic. All right.